Imagine a shadow moving through the night sky, unseen, unheard, undetected. This is not a myth or a ghost, but a marvel of modern engineering, the stealth aircraft. These machines are the pinnacle of military aviation, designed to slip past enemy defenses as if they were never there. The idea of an invisible aircraft has fascinated both military planners and the public for decades. Stealth technology has fundamentally changed the rules of aerial combat. Before stealth, air power relied on overwhelming force. Now, it's about deception and surprise. An aircraft that can't be tracked by radar can strike deep within enemy territory with precision. This capability gives a nation a decisive advantage, enabling surgical strikes with minimal risk. Stealth is not a single technology, but a blend of design principles, shaping to deflect radar, special radar-absorbent materials, and careful management of heat and electronic emissions. Every detail, from engine intakes to cockpit canopy, is engineered to minimize detection. Creating a true stealth aircraft is a delicate balance of aerodynamics, materials, science, and electronics. The story of stealth is one of secret projects, brilliant minds, and Cold War intrigue. We'll explore its origins in World War II, the breakthroughs that led to icons like the F-117 and B-2, and the modern era of air dominance. We'll also look to the future, where stealth continues to evolve in unexpected ways. This is the untold history of how humanity mastered invisibility in the sky. Welcome to the world of stealth. Let's begin our journey into the shadows. The art of being unseen has never been more powerful. The story of stealth begins in World War II, when radar changed the face of aerial warfare. Radar could spot enemy bombers from miles away, giving defenders a crucial edge. The Germans responded by seeking ways to make their aircraft less visible to radar. The Horten Ho 229, a radical flying wing made mostly of wood, was one of the first attempts to reduce radar detection. Its shape and materials hinted at the principles of modern stealth, though it never saw combat. After the war, the Cold War's high-stakes standoff pushed both the US and Soviet Union to develop powerful air defense networks. American spy planes like the U-2 flew high to avoid detection, but when one was shot down in 1960, it was clear that altitude and speed were no longer enough. The quest for true radar evasion began in earnest. Early efforts included radar-absorbent paints in special shapes, as seen on the SR-71 Blackbird. The SR-71 was fast and high-flying with some stealthy features, but it relied on speed for survival. These early lessons laid the groundwork for the next leap, making aircraft truly hard to see. The era of stealth was about to begin. The challenge: build a plane that could disappear from radar. The solution would change air combat forever. The race for invisibility was on, and it all started with the need to outsmart the electronic eye. The breakthrough in stealth came from Lockheed's Skunk Works, led by visionaries like Kelly Johnson and Ben Rich. In the 1970s, DARPA challenged engineers to design an aircraft nearly invisible to radar. The Skunk Works team turned to Soviet physicist Pyotr Ufimtsev's equations, realizing that flat, faceted surfaces could deflect radar away from its source. The result was the bizarre, hopeless diamond, a shape that defied conventional aerodynamics. This radical design required a computer-controlled fly-by-wire system just to stay airborne. The project, codenamed Have Blue, produced two secret demonstrators tested at Area 51. In 1977, Have Blue flew, and proved nearly impossible to detect on radar. Its radar cross-section was the size of a small bird, a revolutionary achievement. Both prototypes were lost in accidents, but their mission was accomplished. Have Blue validated the concept of a faceted, low-observable aircraft. The age of true stealth had arrived. The next step turned this radical idea into an operational weapon. The world would soon meet the F-117. The F-117 Nighthawk was the world's first operational stealth aircraft, built on the lessons of Have Blue. Its faceted shape and radar-absorbing materials made it nearly invisible to enemy radar. Engines were hidden, exhaust cooled, and even the canopy was gold-coated to deflect radar. Developed in secrecy, the F-117 trained at night in the Nevada desert, shrouded in mystery. The world saw it for the first time in 1988, but its true power was revealed in the Gulf War. F-117S slipped past dense Iraqi air defenses, striking key targets in Baghdad with precision. They flew less than 2% of sorties but hit over 40% of strategic targets, without a single loss. The F-117 proved stealth was a battle-winning technology, not just theory. it changed warfare, showing that invisibility could be more powerful than speed or firepower. The Nighthawk's legacy, a new era of air power where being unseen meant total dominance. The world would never look at the sky the same way again. Stealth was now a reality. While the F-117 was a tactical marvel, the U.S. Air Force wanted a stealth bomber with global reach. Enter the B-2 Spirit, a flying wing designed to slip past the world's most advanced defenses and deliver massive payloads. Unlike the F-117's sharp angles, the B-2 used smooth, flowing curves to scatter radar. Engines were buried, exhaust cooled, and the entire surface coated in radar-absorbent materials. Its radar signature is said to be as small as a large insect, despite a wingspan rivaling a commercial airliner. The B-2 can fly from Missouri to anywhere in the world, strike with precision, and return home, no forward base needed. First used in Kosovo, it's since flown missions in Afghanistan, Iraq, and Libya. The B-2's complexity and cost limited production to just 21 aircraft, but its impact is immense. It redefined strategic bombing, combining heavy payload with near invisibility. The B-2 stands as a symbol of American technological prowess and the evolution of stealth. The flying wing had finally come of age. With the Cold War's end, the next challenge was a stealth fighter that could dominate the skies, the F-22 Raptor. The F-22 combined stealth, speed, agility, and advanced sensors for unmatched air superiority. Its shape and internal weapons bays keep it hidden from radar, while Super Cruise lets it fly supersonic without afterburners. The F-22's AESA radar and sensor fusion give pilots a complete picture of the battle space, seeing enemies before being seen. In training, the F-22 achieved staggering kill ratios against older fighters. Only 187 were built due to cost, but the Raptor set a new standard for air dominance. It proved that stealth could be integrated into a high-performance fighter, not just bombers or attackers. The F-22 is the ultimate expression of air superiority, owning the sky through invisibility and information. It's a technological marvel, unmatched to this day. The Raptor redefined what a fighter could be. Stealth had reached new heights. The future of air combat had arrived. After the F-22, the next step was a versatile, affordable stealth fighter for multiple services and allies, the F-35 Lightning II. The F-35 is a multi-role quarterback, designed for air-to-air, ground attack, and intelligence missions. 3 variants serve the Air Force, Navy, and Marines, sharing a common design to reduce costs. Its advanced sensors, 360-degree cameras, and helmet display give pilots unmatched situational awareness. The F-35 can securely share data with other forces, acting as a force multiplier. Despite controversy and cost overruns, it's now entering service worldwide. The F-35 democratizes stealth, bringing 5th-generation capabilities to dozens of air forces. It's changing the global aviation landscape, making stealth the new standard. The F-35 is the backbone of Allied air power for decades to come. Versatile, networked, and nearly invisible, it's a lightning strike in modern warfare. The future of stealth is here, and it's everywhere. Stealth technology is still evolving as detection systems grow more advanced. The future may include active stealth, like plasma clouds that absorb radar, or new metamaterials that bend electromagnetic waves. Engineers are also applying stealth to drones, like the RQ-170 and RQ-180, for high-risk intelligence missions. Unmanned combat air vehicles could soon fly alongside manned jets, carrying weapons and sensors into danger zones. Artificial intelligence will help pilots and drones process vast sensor data, identify threats, and even make combat decisions. The next generation of stealth will blend shaping, materials, electronic warfare, and AI. It's a multi-layered approach, no single silver bullet, but a web of innovations. The goal: stay ahead in the endless cat-and-mouse game of detection and evasion. The unseen horizon is full of possibilities. Tomorrow's aircraft will be even more elusive and capable. The art of invisibility is only getting smarter. The future of stealth is limited only by imagination. From wooden wings to AI-driven drones, stealth is a story of relentless innovation. It began with a simple need to hide from radar and sparked a revolution in air power. Stealth changed military doctrine, making surprise and impunity the gold standard. The F-117, B-2, F-22, and F-35 each mark a chapter in this ongoing saga. These aircraft are more than weapons, they're symbols of technological leadership. Stealth's impact extends beyond the battlefield, driving advances in engineering and inspiring new generations. The principle of invisibility remains as relevant as ever, shaping the future of warfare, the ultimate advantage, to know without being known. The quest for invisibility is now a permanent part of modern conflict. The most powerful weapon is often the one you never see coming. The legacy of stealth endures, in every shadow that passes overhead.